Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, we will learn how to develop client and server-side programming solutions on Azure Cosmos DB. In this unit, I will walk you through how to use the Cosmos DB SDK for .NET to interact with your Cosmos DB and create or query items. We will look at the different classes and methods available to create or query resources and create resources then using the Azure Cosmos DB .NET version 3 SDK. You can use the API for NoSQL SDK across multiple platforms, including .NET version 3, Java, JavaScript, or Python SDKs to do these tasks. This video focuses on Azure Cosmos DB .NET SDK version 3 for API for NoSQL using the Microsoft Azure Cosmos NuGet package. Moving on to the demo portion, I will show you how to get information about any Azure Cosmos DB SDK and how to get started. In this video, I will show you how to get information about the Cosmos DB SDKs and how to get started if you want to programmatically access or interact with the Cosmos DB instance. I have the Azure portal open right now and I'm looking at a Azure Cosmos DB account. If you don't have any idea how to start, if you don't have any data yet, then a good starting point is a quick start. Quick Start is built into the portal here as an example. So if I open this up for my account, you can see it supports currently 4 different platforms just for this specific Quick Start example, where you can go ahead and create a sample database with some sample data in a container. So if I do this here, it creates behind the scenes in that account a database called to-do list with a container called items. And in that container, we have a number of different items to play with. Once this is created, I can then download an application for each of those platforms. It doesn't matter. You can just create it once and then download a sample of your choice. So even if I created this now in .NET, I can go ahead and download now an application for Node.js. And in that application, it's already pre-configured to connect to that specific Azure Cosmos DB account. It has already the connection string in it. And then you can go ahead and interact, create items, query them, see what it all offers in the SDK. And then you can also open up the Data Explorer then later on to navigate and see if that actually worked okay, if you want to check from both sides. That's one good starting point, but there's more. On Microsoft Learn, if you go to the Cosmos DB documentation, you will find that there's not only a ton of documentation about every concept and all the different elements of Cosmos DB, but it has also for each of the different APIs documentation on quick starts, tutorials, and samples. So here you will find even more quick starts for the different languages that we support. It will explain you with code examples how to create a database, how to get one, how to read properties of an item and all of different things. And we even have a really huge list of different samples hosted on GitHub for each of those different languages and APIs respectively. So if I'm interested in working with Java on some examples, I will go here on that side. I pick the version that I'm interested in right now. And then if you scroll down, you will find a GitHub link that will bring you to the repository. And in that repository, we'll explain what you have in here. They all look a little bit different, determining how that language is organized in here or how these samples are organized. And in here, in the main example, I have this main source, I have a lot of different examples how to do certain operations. There's a ton of information here. You can just use this, copy paste it into your scenarios, and then try it out. The third option is to use the Data Explorer, which I opened up here in a separate window. And in this, you have in the overview, in the welcome page that you see right now, you can start a quick start from here right away. And that is walking you through the creation of a database. It will even give you some explanation on the different steps in here. You fill this everything out. It walks you through the creation of a database, a container, and then you have also some data to play with. And other than this, you have some nice links here about patterns or best practices about certain components, or even links to a full learning path on how to get started using the SDK if you need the full guidance with each detailed step. In this video, I will show you how to use the Cosmos DB.NET SDK to get access to a Cosmos DB instance to a specific container and query some of the items in there. So we're looking at my Cosmos DB account, and as you can tell, I have different databases and containers in that account already, and I would like to work with the Cosmic Works database. I have the Data Explorer already open in a different tab in full screen so you can see it better. And this is the Cosmic Works database. And here is the product container. And in that product containers, I have a number of items available. And each of these items has a different category assigned to it. So home, grocery, jewelry, and so on. And there are books in there. So what I want to do in code is to run a query that will turn out a list with all the books that have the specific category books assigned to it. Now, as you saw right now, when we query all the products, there are a lot more. So it just, I don't know how many exactly, but we have a couple of hundreds in here. And the idea is to run that query looking for only category ID books. And this should return 13 different items. And one of them is being the awesome granite keyboard, which is a strange title for a book, but yeah, what do I know? Maybe they have written the best book about this. It's also quite expensive for a book, but yeah, let's just don't go into this too much. How can I access the data? I have prepared some code already, some C# code, and in this code I have added a package using the Microsoft Azure Cosmos library. So that gives me all the instances, the methods that I would like to use in this. Now, the idea here is to instantiate a Cosmos client, connect to my container, sorry, not to the container right away, but to the account. Once I have that connection to that endpoint that is provided by the account, I will get a reference for the database Cosmic Works that I just showed you. And then next we will connect or reference a specific container, which is our product one. And then we run a query. That's the same query that I just showed to you. And this query will be using the so-called feed iterator, where we will run the query, we get a bunch of different results back, and then we can use this to iterate over it and say if it has results, then just print them out on the console saying found item and the name of the product. So that's the code. Really simple example, also part of a quick start on Microsoft Learn. But this is running on my computer right now, so I need to have an endpoint URI so that it knows which instance am I connecting to, and I need some permissions. So because my code here doesn't have any identity on its own, so I need to have an access key. So I get this from the Azure portal. I will navigate on the left-hand side to the keys section of my Cosmos DB account. And here we have, first is the URI, that's the endpoint that it needs. If I go back and paste this in here, and then I pick either the primary or the secondary key for this. And obviously, since these are kept secret, they are not exposed if I don't push that button for you. I should never ever do what I'm doing right now. And the comment says it as well. This is for demo purposes only. A secret like this should never go into a plain text file. Please use Key Vault or other measures to protect this and retrieve the information at runtime and not keep it in a file store. But for demo purposes, I will do this right now. So, okay, I have saved it. It's all good. So let's see if that works okay. So we will run it. And here comes the list of, I didn't count, but it looked like 13 items. Here comes the list of our books. And we see in the first row, we have that awesome granite keyboard in here as well. So yeah, that worked. Okay, so that is how I query items from a .NET example in a Cosmos DB account. And of course, on Microsoft Learn, you will find the same operations and others like creating or deleting items in not only .NET, but also Java, Python, and other languages and platforms as well. In this unit, I will show you how to create and use stored procedures in Azure Cosmos DB. We will look at how you write stored procedures using JavaScript and understand transaction continuation and bounded execution. Imagine an online store with thousands of daily orders. When a customer places an order, a stored procedure can handle inventory updates, calculate shipping costs, and generate invoices, all within the database. This ensures consistency and reduces network overhead. When using the API for NoSQL in Azure Cosmos DB, you can create stored procedures, triggers, and user-defined functions with JavaScript. You can use JavaScript to write your logic and run it inside the database engine. Stored procedures are registered at the container level and can perform create, update, read, query, and delete operations on items within that container. Here's how that works. Let's go to a demo. In this video, I will show you how to create, register, and call a stored procedure in a container of an Azure Cosmos DB. We're looking at the Data Explorer. We're looking at my database Cosmic Works in my Cosmos DB account, and this has a container called products, and in that container we see that there's a number of items stored, some random products that are stored in here. Now the idea of a stored procedure is of course that we would like to batch certain operations together. So a very common approach would be to create a stored procedure that is creating new items in a specific standardized form. So let's do this. A storage procedure is always registered at the container level. So it's not at the database level, it's one beneath. You can have different stored procedures per container. So we right click or use the context menu for the products container. We choose this new stored procedure feature from here. And now I see just a sample. This is all JavaScript code. That's the only code that is currently, or that's the only language that's currently supported. So I would like to create new documents, new items from here. So I will give my stored procedure an ID or a name. And then I have the code that I want in here already in the clipboard, and this is what it does. So it's taking a title, it's asking for a name property to provide that as a title for this item, and the first one, the category ID, will be selected, and that is also in this scenario here, that is the partition key for my products container. And then we have a method here that is checking that we have the method executed that creates a document and then checking if an error occurs and otherwise returning it. So let's store this. Just see, because the save button is grayed out, so now it is there. So let's save this, and then by saving it will also be registered at the container level as before. And from that point on, now it turns up in here as a new stored procedure, and if I click this or select it, I can then execute it. Sometimes the UI is a little bit yeah, let's say a little bit needs to be a little bit convincing, because right now I don't see the execution button anymore. So yeah, again, just changing something back and forth works in this sense. And now I can execute this. When I execute this, it asks for the partition key value and input variables that I have provided. And since I know that the first one is going to be the category, I will use the category demo for this. And then just let's create a first demo. Actually, a first document. That's not the first demo. Okay, so let's just use this, execute this, and that looks good. I see here a status match saying, yeah, that was okay. And I even see here the outcome of it coming back with the ID and some other internal properties of that executed function. So let's do this another time because I just want to show you that we also have different documents. So let's make this a second one. Now with this, I have used the stored procedure to already add 2 additional items to my container. And I want to do the third one in code now that I have my stored procedure available, because you won't do this manually, right? Won't you? So this is the code that I have. It's a .NET example, a C# example, very simple one where I just trigger that stored procedure. So I'm leveraging here again the library for Microsoft Azure Cosmos to have the means of instantiating a client. And I'm connecting to my Cosmos DB account by using the endpoint URL and an access key. As you know, this is not best practice. Never do store your keys in a plain text file. This is really just for demo purposes. Then it's connecting the Cosmos client, getting a reference for the database, getting one for the products container. And here is the part where it executes the stored procedure. And it finds it by name, create doc, and then provides the same parameters we have used. The partition key is the demo one. You always have to reflect your partition key and your stored procedure in the code that you use, and we will create a third document. And then we'll just print out the result. So let's move to the terminal here, and then let this just run. And this looks pretty much like what we had in the portal. There's a third document created and so on. By the way, since I have not shown this to you and I had it already in the code, where do you get that endpoint URL and access key again? Either from the Azure portal, or you can also get this from within the Data Explorer. On the Home tab, you have a Connect tile, and with that Connect tile, you get all the information you need. Be careful when someone is standing behind of you, because this is not obfuscated like in the Azure portal. Then everyone could just take a picture of this and use these secrets to get access to your Cosmos DB. But you have it all here in if you develop. Now, the last part is, now I would like to show you that there is indeed now also these 3 added items in my container. So what I will do is I will run another query. No, I don't want to run an existing one. And what I want to do here is to query the products for the category demo. That is the category, the ID that I used for all my examples. So if I run that query, I would expect to see 3 items in total. And here they are, the first, the second, and the third document, all created by using that create doc stored procedure by the portal execution, and then the third one via code. Imagine that you're trying to work, but every 5 minutes, someone comes in and asks, have you finished this task? No, you haven't? Okay, too bad, time's up, undo it. Now that I'm saying it out loud, it sounds quite familiar, but okay, that's a different story. Cosmos DB ensures throughput and provides availability as high as 5 nines. This is only possible when it controls what runs and for how long. JavaScript functions may use up a lot of request units in a short time. This is why Azure Cosmos DB limits stored procedures by bounded execution time. So operations that may take a long time should either be divided or repeated until all work is done. Do you know what the timeout limit is for stored procedures? Now it's not 5 minutes, it's 5 seconds. And this is not just for stored procedures. It applies to all JavaScript functions, triggers, and user-defined functions too. If an operation is not completed within that time limit, the transaction is rolled back. You have 2 options to make sure your JavaScript functions don't exceed the time limit. You can either write them to finish within the limit, thumbs pressed, or use a continuation-based model to pause, resume execution. To make it easier to develop stored procedures and triggers that handle time limits, all functions under the Azure Cosmos DB container, for example, create, read, update, and delete, return a Boolean value that shows whether that operation will complete. If this value is false, it means that the procedure should end execution because the script is using more time or provision throughput than the set value. Operations that are queued before the first rejected store operation are assured to finish if the stored procedure ends in time and doesn't queue any more requests. Therefore, operations should be queued one by using JavaScript's callback convention to control the script's flow. Because scripts run in a server-side environment, they are strictly regulated. How can we use such a continuation-based model to pause, resume execution in our implementation? Functions can return any value. You can use this value to continue long-running functions after the time limit set by the server is reached. For example, you might have a function to upload millions of documents. If the time limit is reached before all documents are uploaded, you can return a pointer to show how much your function completed in the document upload. This will make it simpler to resume processing in a new function iteration. In this unit, we talked about how to write sort procedures using JavaScript and understand transaction continuation and bounded execution. In this unit, I will show you how to create triggers and user-defined functions, UDFs, in Azure Cosmos DB. We will talk about and also see how to write triggers and user-defined functions using JavaScript. Azure Cosmos DB supports pre-triggers and post-triggers. Pre-triggers are invoked before modifying a database item, and post-triggers are invoked after modifying a database item. Triggers must be specified for each database operation where you want them to execute. Can you think of a few use cases in your solution? Pre-triggers can validate incoming data before it's added to the database. For example, if a product description meets certain criteria. If a new item lacks essential properties like a timestamp, the triggers code can enrich it by adding the missing information. Post-triggers are excellent for logging purposes or additional steps you want to be executed after an item is written to the database. After an item is modified or deleted, a post-trigger can capture relevant details and store them in a separate audit log collection, such as the user who made the change, a timestamp, and the affected item. User-defined functions, UDFs, allow users to expand the API for NoSQL query language syntax and execute custom business logic with ease. They can only be invoked inside queries. An UDF can be used to parse or extract substrings, to aggregate data over time intervals, or use data properties and calculate values. Let me show you examples for triggers and UDFs in the next demo. In this video, I'm going to show you how to create and use triggers and user-defined functions, or UDFs, in Azure Cosmos DB. We're looking here at the Data Explorer. I have this CosmicWorks database with a container called products in here and some items that list these products. I want to create two things. One is a pre-trigger that adds or checks if a timestamp is added to the records, to the items, and if not, it adds this when the items are created. Like with sort procedures, both user-defined functions and triggers are created and registered on the container level. So I will use that context menu. I will go to new trigger, and that opens up this item for me. So I could give this any name. At timestamp would make more sense here. And then I select either this is a pre or post trigger. Pre happens before the item is created, post obviously after this. Then I also can limit this to the operations. In my case, it makes most sense to do this only when a new item is created. Maybe at some point it would also could be with a replace, but yeah, create makes the most sense. And then in here, I will just make my code available that I already have, which looks like this. So we're just having the normal context for the incoming request. We will get the body of that request so we can read all the properties. We will check if there's a property timestamp in it, and if not, we will go and update this. And yeah, that's all we have in here. So I will go and save this trigger. Now this trigger is now executed whenever there's a new item created. Now while this is saving, let's talk about user-defined functions. User-defined functions are different from stored procedures and triggers because I will not really use them to create items or to modify items, but I will use them in queries. So let's have a look what that means. So start with the same thing. UDF is the short form for user-defined functions. So I will create one, and in this example, I'd like to create a super simple one just to show you what you can do with this. So I would like to have one that takes an input and then multiplies it by a number here. Just to calculate the tax. It's not real tax, but yeah, that's the idea behind it. Just to show you a really simple example. I go ahead and save this function that is called tax. And then next, how can I use this? I will use this in a query. So now that it is updated, I will go ahead and create a new query. And I have one in here that is using now my UDF called tax. It provides the property price from the products that are in my items list in the container, and then gives this a name, an alias, price with tax, and then prints this out as a result. So this calculation happens while querying. It's not stored in the properties of this. So I will add this by using that function. So let's execute this. And here you have the results of the first ones that we see. The price is a property of each item, and this is then the calculated value price with tax that we have gotten out of our query statement here, where we utilized a user-defined function. In this unit, we looked at how to write triggers and user-defined functions using JavaScript. In this unit, you will learn how the change feed in Azure Cosmos DB can be used to simplify scenarios that need to trigger a notification or send a call to an API based on a certain event. Change feed enables real-time processing of data changes. Use it to update dashboards, generate insights, and trigger alerts as new data arrives. Create aggregated views of data using change feed. For example, maintain a summary of sales data or user activity for efficient querying. Keep multiple databases or regions in sync. Change feed helps propagate changes across systems for high availability and disaster recovery. Build event-driven systems by reacting to changes. For instance, trigger notifications, process orders, or update caches. Audit changes for compliance or debugging purposes. Change feed provides a reliable record of all modifications. Let's have a look at how to implement the change feed notifications. Change feed in Azure Cosmos DB is a persistent record of changes to a container. By monitoring an Azure Cosmos DB container for any changes, change feed produces an ordered list of documents that underwent changes in the order they occurred. The persistent changes can be processed asynchronously and incrementally, and the output can be distributed across one or more consumers for parallel processing. There are two methods to access the change feed using a push model: Azure Cosmos DB triggers for Azure Functions, and the change feed processor library. Azure Functions provides the simplest way to connect to the change feed. You can create small reactive Azure functions that will be automatically triggered on each new event in your Azure Cosmos DB container's change feed. The change feed processor is included in the Azure Cosmos DB.NET version 3 and Java version 4 SDKs. It makes it easier to read the change feed and spreads the event processing among multiple consumers efficiently. There are four main components of implementing the change feed processor. The change feed is created from the data in the monitored container. The change feed shows any additions and changes to the monitored container. The release container keeps track of the state and helps to process the change feed with multiple workers. The release container can be in the same account as the container that is being monitored or in a different one. The change feed processor runs on a compute instance that monitors change. The platform determines what the compute instance is, such as a virtual machine, a Kubernetes pod, an Azure App Service instance, or a real physical machine. The delegate is the code that specifies what you, the developer, want to achieve with each batch of changes that the change feed processor consumes. Here's a demo to show you how to work with the change feed.
In this video, I will show you how to use the change feed processor feature in the .NET SDK to build an application that gets a notification when an item in the given container is created or updated. So to do this, I have already deployed a NoSQL API Cosmos DB in the serverless mode. I have created a database called Cosmic Works, and this database currently has no containers. So I will create first the so-called monitored container. And that is the container where I want to be notified if any updates, any changes are made to the records in it. So we will name this products, and I'll make it pretty easy here. And since I'm going to use some example data that is using the category ID as a partition key, I will set this up. The rest will just remain at the default, so that's okay. So that will be our monitor container. So that is the one that has the data from which the change feed is generated. Any inserts, any updates to this container are reflected then in the change feed of this specific container. So now I have products. Let's create another one. And this will be the so-called lease container. So we will call it product lease, and then the partition key will be, and you know, I'm really not that creative with this, so it will just be partition key. I will make it look good. Okay, so the lease container. This is the container or a container that acts as state storage and helps us coordinate processing the change feed across multiple workers. The lease container can be stored in the same account, which we just did, or it could also be in a separate account. So we could have this in another Cosmos DB just to keep the state. Now, I have these different containers, and obviously since I created them there's nothing in there, right? So they're fresh, there's nothing in it. Now, let's switch over to Visual Studio Code. Now here we see a script CS file, C# file, where I'm using the Microsoft Azure Cosmos container class that ships with a series of different methods to build the change feed processor. What we will do to start is first, of course, provide the endpoint that I copied over from the portal and the access key. Yes, I did it again. And I put the comment on here, so this is for demo purposes only. Please don't put any secrets or the access keys into your code files. Use Key Vault for this. And then we instantiate a client, a Cosmos client, with these information. Now, then we start by building a reference to the monitored container. The monitored container is the one that has the data that we are interested for. And then we have the lease container, which is our products lease that we just created. And this is the one that we use to store state storage or state in general of our feed in our application. And this helps us coordinating this, as I explained before. So this gets the reference to the containers. Now, the most important part here is then that we have this specific delegate variable called the handle changes of the types changes handler. And this is our change feed instance that we will then use to basically listen for any changes, and if we detect any operation that happens on the monitored container, we'll print it out. So I have left a few comments in here, added them using Copilot so that you can also read this a bit more, so you can see the different parameters. And what we have then is we get the change feed processor build. This will list all the different changes in batches, and we will have this continuous listening until we do actually something and see what's happening. Now, this is the code. Now I would like to run this example now in the terminal, and I have this divided into two options. So on the left hand side, I am in that folder where I have the script CS running. So first of all, I will just run this. So it will connect to the Azure Cosmos DB and connect to the change feed of that particular product's container. And it is doing this right now, so it's listening for changes. On the right hand side, I will use a command line tool that is called Cosmic Works. This is a tool that you can install by using this line here. I will just show you this. I have already copied this, but if you use .NET tool install Cosmic Works, this is an older version, but it allows you to get some sample data into your Cosmos DB, which is coming in handy here right now. And then I will use, as the next part, I will use Cosmic Works with a variable that I filled in earlier, where we have the Cosmos endpoint, same thing that we have in the application running now on my local machine, and the key. And I just have there different data sets that it provides, and product is what I'm interested in. Basically what this is doing is it will create 1,000 different items with random product information, names and descriptions and prices and so on in the product's container. And we should then after a while see that on the left hand side we see those changes being read from it. So it will create a few, and we see on the left hand side it's picking up these detections or these detected operations and printing them out. Yeah, that was already it. So obviously my code is not doing anything else other than just printing out that message, so giving us a notification of what has happened. I could also use this to copy data. Whenever there's something created in the products container, I would like to have a copy of that item created in a different container that uses a different partition key, for example, for performance reasons, better query times. Or I could use this to process the data in a certain way and then just provide that information as a logging or auditing operation in a different container. So let's just go back maybe for a bit and then have a look at our items. So right now it's still empty. I need to refresh, and then you will see that I have now items in the products container. So as I said, just random products here with different categories, names and descriptions and so on. And when we check what is in the product list, it is really just using certain information that it is using internally. So it's not much that I can do with this, but it's providing information about the lease token and when did it run a last action and what was used for this. But it doesn't have any, let's say, details of what we just saw before. So it will trigger every time there's a change made to the container products, which are monitor one, it will just act upon with the code, and we decide in our console application or any other application what we do with these kinds of events.
So in this last unit, we went over this change feed notifications and how to implement them. So congratulations on learning how to develop client and server-side programming solutions on Azure Cosmos DB. With its seamless integration with popular programming frameworks and comprehensive SDKs, you're ready to unleash the full potential of your applications. Dive into the world of Azure Cosmos DB and embark on a journey of innovation and efficiency in data management. Thanks for watching. Keep on learning.